Hi, in this video we will study stop and wait ARQ protocol. So we will discuss these topics under stop and wait ARQ protocol. So first we will discuss the problems of stop and wait protocol, and then we will see how stop and wait ARQ protocol solves these problems. Next we will study how sequence numbers are added in stop and wait ARQ protocol. Then we'll discuss the design of stop and wait ARQ protocol. Then we will also go through the main points of the algorithm at the sender and the receiver side. And then with an example we will study how stop and wait ARQ protocol actually works. So as discussed in the previous videos, we know that the protocols at the data link layer for flow and error control are divided into two types, that is for noiseless channels and for noisy channels. These two protocols for noiseless channels, that is simplest and stop and wait protocol, we have already discussed in the previous videos. So in this video we will study stop and wait ARQ protocol for noisy channel. And ARQ stands for automatic repeat request. So let us start with stop and wait ARQ protocol. So first let us discuss some of the problems of stop and wait protocol and how stop and wait ARQ protocol handle these problems. So this stop and wait protocol we have already discussed in the previous video. So as discussed in the previous video, we know that in stop and wait protocol, first the sender will send one data frame and the receiver, after receiving the data frame, will send an acknowledgement frame. So only after the acknowledgement frame is received by the sender, then only it can send the next data frame. So the first problem of stop and wait protocol is lost frame. That is, say suppose while sending the data frame is lost. So in this case the receiver will not be aware and it will keep on waiting for the data frame. Similarly, the sender will not be aware that the frame is lost and it will keep on waiting for an acknowledgement from the receiver. Next problem of stop and wait protocol is lost acknowledgement frame. That is, say suppose when the receiver sends an acknowledgement frame, the acknowledgement frame gets lost. So in this case the sender will not be aware and it will keep on waiting for an acknowledgement frame, because without getting an acknowledgement it cannot send the next data frame. So in order to solve this problem of lost data frame and lost acknowledgement frame, the stop and wait ARQ protocol will use a timer. So after sending a frame, the sender will start a timer, and if the timer expires and there is no acknowledgement to the sent frame, then the frame will be sent again. Similarly over here, if the timer expires and there is no acknowledgement, then the frame will be resent. Now you may say that if the frame is resent over here, then it will be a duplicate frame because the data frame was already received. So in this case, when the receiver receives a duplicate frame, it will discard the duplicate frame and it will only send an acknowledgement to the sender. So after receiving the acknowledgement, the sender will know that the receiver has received the frame. So another problem of stop and wait protocol is that the data frame may be out of order or the data frame may be a duplicate frame, because in stop and wait protocol there is no way to identify a frame. Say for example over here the data frame is sent 2 times. So over here the receiver will not know, because in stop and wait there is no way to identify the frames. Also the acknowledgement frame may be out of order or it may be a duplicate frame. So in order to solve these problems of stop and wait protocol, this stop and wait ARQ protocol will have sequence numbers for the frames so that the frames can be easily identified. So using the sequence numbers, the receiver will know if the frame is a duplicate frame or if the frame is out of order. So this stop and wait ARQ protocol is used for noisy channel, and since it is used for noisy channel, the data in the acknowledgement frames may get corrupted during transmission. So if the frames are corrupted, then the stop and wait ARQ protocol will not accept the corrupted frames, and in that case the frames will have to be retransmitted. And in order to check if the frame is corrupted or not, the redundant bits are added to the frame. So as said earlier, the sequence numbers are added in stop and wait ARQ protocol. So let us discuss how the sequence numbers are added in stop and wait ARQ protocol to identify a frame. So this protocol uses only two sequence numbers to identify a frame. That is, the sequence number may be either 0 or 1. So the data frame which is sent from the sender to the receiver will have sequence number either as 0 or 1. And the sequence number at the sender side will be denoted by SN. So initially the first frame will be assigned sequence number as 0. Then after sending one frame, the SN will point to the next sequence number. So the next frame will have a sequence number as 1. Then the next frame will have sequence number as 0 and so on. Similarly, the acknowledgement frame which is sent from the receiver to the sender will have acknowledgement number either as 0 or 1. So the acknowledgement number at the receiver side will be denoted by RN, and the receiver will always send an acknowledgement for the expected frame. So say suppose the receiver has received frame 0 and it is waiting for frame 1, then receiver will send an acknowledgement to frame 1, which means that it will inform the sender that it wants frame number 1. So receiver will always send an acknowledgement for the expected frame. Acknowledgement for frame 1 meaning it will send an acknowledgement frame with acknowledgement number as 1. Next, let us discuss the design of stop and wait ARQ protocol. So this stop and wait ARQ protocol will be implemented at the data link layer. So at the sender side, the data link layer will get the data from the network layer. Then at the data link layer, it will add its information and it will make a frame and pass the frame to the physical layer. Then the physical layer will send the frame over the transmission medium. Then at the receiver side, the data link layer will receive the frame from the physical layer. Then at the data link layer, it will extract the information for it, and then it will deliver the data to the layer above it, that is to the network layer. Then after delivering the data link layer will send an acknowledgement frame to the physical layer. The physical layer will send the frame over the transmission medium. Then at the receiver side, the data link layer will receive the acknowledgement frame from the physical layer. So the design is similar to the design of stop and wait protocol which we had discussed in the last video. But over here, the data frame which is sent from the sender to the receiver will have a sequence number, and the sequence number will be denoted by SN. Similarly, the acknowledgement frame which is sent from the receiver to the sender will have an acknowledgement number which is denoted by RN. So like stop and wait protocol, this stop and wait ARQ protocol also will have events. So the first event at the sender side is request from network layer. That is, the data link layer will be able to send the frame only when network layer has data to send. Then the second event is notification from physical layer. So the data link layer will be able to receive the acknowledgement frame only when there is a arrival notification from the physical layer. And the third event is timeout, meaning after sending a frame, the sender will set a timer, and if the timer expires and the acknowledgement is not received, then the frame will be resent. Similarly, at the receiver side, there is one event, that is notification from physical layer. That is, the data link layer will be able to receive the data frame only when there is an arrival notification from the physical layer, or only when the physical layer has a data frame to send. Next, let us discuss the algorithm of stop and wait ARQ protocol. Now, this is not the entire algorithm, but just the main points from the algorithm. So, let us discuss the main points of the algorithm at the sender side. Now, the sequence number of the data frame at the sender side is denoted as Sn, and initially the Sn value is set to 0. And we know that the sequence numbers can be either 0 or 1. So initially we will set it to 0. That means the first frame which will be sent will have a sequence number as 0. Next, if the data arrives from the network layer, then the data link layer will receive the data. It will make a frame and it will send the data frame with the sequence number. Now initially the sequence number was set to 0. So it will send a data frame with sequence number as 0. That is, the first frame will be sent with sequence number as 0. And after sending the frame, the sender will start the timer. Also, after sending the data frame, the Sn value will be set to the next sequence number. So initially Sn value was 1. So after sending one data frame, Sn will be set to the next sequence number, that is 1. Next, if the acknowledgement frames arrives from the physical layer, then the data link layer will receive the frame, and if the frame is not corrupted and if the acknowledgement number is equal to Sn, then the sender will stop the timer. So how this actually works, we will see with an example later. But this actually just means that if the acknowledgement is received correctly, then the timer will be stopped. Also, one more event at the sender side is the timer. That is, if the acknowledgement frame is not received and if the timer expires, then the timer will be restarted and the previous frame will be resent. That is, the frame for which the acknowledgement was not received, that particular frame will be resent. Next, let us discuss the main points of the algorithm at the receiver side. Now, we know that the receiver will send an acknowledgement to the sender. So, the acknowledgement number in the acknowledgement frame is denoted by Rn, and initially the Rn is set to 0. Next, if the data frame arrives at the receiver side from the physical layer, then the data link layer will first check if the data frame is corrupted. And if the data frame is corrupted, then the receiver will not do anything. That is, it won't send any acknowledgement. So if the receiver is not sending any acknowledgement, so in that case, the sender will resend the frame after the timer expires. So if the frame is not corrupted, it will check if sequence number is equal to Rn. And sequence number is the sequence number of the data frame. So if sequence number is equal to Rn, then the data link layer will extract the information for it. That is, it will extract the information for it from the frame and then deliver the data to the layer above it, that is to the network layer. Then after delivering the data, Rn will be set to the next acknowledgement number. So initially Rn value was 0. Then after delivering the data, Rn will be set to the next acknowledgement number, that is 1. Also, the receiver will send an acknowledgement frame to the sender. So these are the main points of the algorithm at the sender and the receiver side. Next, let us see how the stop and wait ARQ protocol works. So we will study the stop and wait ARQ protocol with an example. So the working is based on this same algorithm which we have already discussed. So consider this is the sender and this is the receiver. So initially SN value will be set to 0, where SN is the sequence number of the data frame. So once the data arrives from the network layer, that is once the data arrives from the network layer at the data link layer, the frame with sequence number 0 will be sent. Sequence number 0 because SN value is set to 0. So frame with sequence number 0 will be sent. Also after sending the frame, the sender will start the timer and the sequence number will be set to the next sequence number. Now initially sequence number was set to 0. So now the sequence number will be set to 1, which is the next sequence number. Then at the receiver side, Rn value is initially set to 0. Now Rn is the acknowledgement number of the acknowledgement frame. So once the frame arrives, it will check if the frame is corrupted using the error detection method. So over here, let us assume that the frame is not corrupted. Now if the frame is not corrupted, it will check if sequence number is equal to Rn. Now over here, the sequence number of the frame is 0 and Rn value is also 0. So sequence number is equal to Rn over here. So in that case, the data link layer will extract the information for it from the frame and deliver the data to the higher layer, that is to the network layer. So after delivering the data, the Rn value will be set to the next acknowledgement number. Over here Rn value is 0, so then it will be set to 1. So after that, receiver sends an acknowledgement for the expected frame. So after receiving frame 0, it is expecting frame 1. So it will send an acknowledgement for frame 1. So it will send an acknowledgement frame with acknowledgement number as 1. So basically it means that the receiver is informing the sender that it has received frame 0 and next it wants frame number 1. Then once the acknowledgement frame arrives at the sender side, it will check if the acknowledgement frame is not corrupted and acknowledgement number is equal to Sn. So over here we will assume that the acknowledgement frame is not corrupted, and also over here the Sn value is 1 and also the acknowledgement number is 1. So acknowledgement number is equal to Sn. So in that case, the sender will stop the timer. So since both the values are equal, the sender will stop the timer. Sender will stop the timer because the frames may not be resent as the acknowledgement was received correctly. So this is a situation wherein the data frame was sent correctly. Also the acknowledgement frame was received correctly. Next, let us consider a situation where the data frame is lost. So when the data arrives from the network layer, the data link layer will not initialize the Sn value to 0 again, but it will use the same Sn value, that is over here Sn value was 1, so Sn value will be 1, so a frame will be sent with sequence number as 1. So after sending a frame, the timer will be started, and also after sending the frame, the Sn will be set to the next sequence number. So over here Sn value was 1, so now Sn will be set to 0, that is the next sequence number. But say suppose this frame 1 is lost during transmission. So if the frame is lost during transmission, then the receiver will not receive the frame. So there is no action at the receiver side, and as a result the receiver will not send any acknowledgement because it has not received any frame. So if the receiver is not sending any acknowledgement, then after some time the timer will expire and the acknowledgement won't be received. So if acknowledgement is not received and if the timer expires, then the timer will be restarted and the previous frame will be resent. That is, the frame for which acknowledgement was not received will be resent. So after sending frame 1, SN was set to 0, but an acknowledgement is not received for frame 1. So as a result, SN minus 1 frame will be sent again. That is, the frame with sequence number 1 will be sent again because an acknowledgement was not received for this frame. That is, acknowledgement was not received for frame 1. So now SN value will be 1 because an acknowledgement was not received for frame 1. So a timer will be restarted and the frame 1 will be resent. Then after sending the frame, SN will be set to the next sequence number, that is, over here SN was 1, so now SN value will be set to 0. Then at the receiver side, when the data frame arrives, the receiver will check if the data frame is corrupted. So let us consider that the frame is not corrupted. So then it will check if the sequence number is equal to Rn. Now the sequence number of the frame is 1 and Rn value is also 1. Rn value is 1 because over here the frame was lost and Rn value was not changed, and the last updated value of Rn was 1. So as a result, Rn value will be 1. So since over here sequence number is equal to the Rn value, the data link layer will extract the information for it and deliver the data to the network layer. And once the data is delivered to the network layer, Rn will be set to the next acknowledgement number. Over here Rn value was 1, so now Rn will be set to the next acknowledgement number, that is 0. After that, the receiver will send an acknowledgement to the sender. So it will send an acknowledgement to the next expected frame. It has received frame 1, so it will send an acknowledgement for frame 0, that is, it will send an acknowledgement frame with acknowledgement number as 0. So basically it is telling the sender that it has received frame 1 and then next it wants frame 0. So when the acknowledgement frame arrives at the sender side, the sender will check if the acknowledgement frame is not corrupted and the acknowledgement number is equal to SN. So let us assume that the acknowledgement frame is not corrupted, and over here the acknowledgement number is 0 and SN value is also 0. So both are equal. So as a result, the timer will be stopped. So the timer is stopped because the acknowledgement has been received correctly. So this is the situation wherein the data frame was lost and how the data frame is resent. Next, let us consider the third scenario wherein the acknowledgement frame is lost. So when the data arrives from the network layer, the data link layer at the sender side will send a frame with sequence number as 0. Sequence number is 0 because currently SN value was 0. So as a result, it will send a frame with sequence number as 0. Also, after sending a frame, SN will be set to the next sequence number. So currently SN was 0, so it will be set to the next sequence number, that is 1. So SN value will be now set to 1. So after the frame arrives at the receiver side, the receiver will check if the frame is corrupted. So let us assume that the frame is not corrupted, and then it will check if sequence number is equal to Rn. Now the sequence number of the frame is 0 and Rn value is also 0. Rn value is 0 because the last updated value of Rn was 0. So both are equal. So as a result, the data link layer will extract the information for it and then deliver the data to the network layer. So after the data is delivered, Rn value will be set to the next acknowledgement number. So the next acknowledgement number is 1. So Rn will be set to 1. Next, the receiver has to send an acknowledgement. So the receiver will send an acknowledgement for the next expected frame. So it has received frame 0. So receiver will send an acknowledgement for frame 1. So it will send an acknowledgement frame with acknowledgement number as 1. So say suppose the acknowledgement is lost during transmission. So if the acknowledgement is lost during transmission, then the sender will not receive any acknowledgement. So after some time the timer will expire, and if the acknowledgement is not received and the timer expires, then the sender will restart the timer and the frame has to be resent. So after sending frame 0, SN value was set to 1, but an acknowledgement is not received for frame 0. As a result, SN-1, that is frame with sequence number 0, has to be sent again. So again SN value will be 0 because the acknowledgement was lost. So the timer will be restarted and the frame 0 will be sent again. Then at the receiver side, the receiver will check if the data frame is corrupted. So let us assume that the data frame is not corrupted. Then it will check if the sequence number is equal to Rn. Now the sequence number of the frame is 0 and Rn value is 1. Rn value is 1 because the last updated value of Rn was 1. So over here sequence number is not equal to Rn. So this condition is not satisfied. So as a result, the receiver will discard the frame. Also over here, since the frame is discarded, the Rn value won't be updated. That is, the value was 1. So it will remain 1 itself because the frame was discarded. Now over here, even though the receiver has discarded the frame, it will send an acknowledgement. That is, it will send the previous acknowledgement, that is the acknowledgement frame with acknowledgement number as 1. So it means that the receiver assumes that the acknowledgement frame was lost and it is sending the same previous acknowledgement again. So it is telling the sender that next it wants a frame with sequence number as 1. Then once the acknowledgement frames arrives at the sender side, the sender will check if the frame is not corrupted. So let us assume that the acknowledgement frame is not corrupted, and then it will check if acknowledgement number is equal to Sn. Now the acknowledgement number of the frame is 1 and Sn value is also 1. So since both are equal, the sender will stop the timer. So the timer is stopped because the acknowledgement was received correctly. So this was the situation wherein the acknowledgement frame was lost and how the data frame is resent. Also in this example, we had assumed that the data frames are not corrupted. But if the data frames are corrupted, then the receiver will not do anything. That is, the receiver will not send any acknowledgement. So if the acknowledgement is not received at the sender side and if the timer expires, then that particular frame will be resent. Similarly, in this example, we had assumed that the acknowledgement frames are not corrupted. But if the acknowledgement frames are corrupted, then the frame will be resent. Next, let us discuss the efficiency of stop and wait ARQ protocol. Now, this stop and wait ARQ protocol is less efficient because over here only one frame is transmitted at a time. So if only one frame is transmitted, then it will waste the bandwidth. Also, the sender can send the next data frame only after receiving an acknowledgement. So it is very slow.